Good morning, students. Today we're going to be covering our Week 7 PowerPoint presentation, talking about enumerations and interfaces, file parsing, and exceptions. So this is located on my website underneath CSA schedule, Week 7, file parsings, exceptions, and arrays. So that's what we're going to be going over today, the first little bit of it. So today's objectives is to recognize when to use enumerated types, otherwise known as enums, when designing a program, how to define, initialize, and use enums, and as well how to implement an interface. We're going to do those three things today. So as we go down through this instructional piece here, an enumerated type or an enum is a special type that provides a predefined fixed set of constants. It is only good to be used when you have a small set of values for like a variable. Say for instance, days of the week. There will only be 7 days of the week, so an enum would be good for that. Directions, north, south, east, and west, being as how there's only 4 main directions, an enum would be very good for this. If you have more than, say, 10 probably, an enum would not be necessary and you would define each variable. But then again, that is up to you and your coding preferences. So an enum, as defined here, is a simple class that predefines all possible instances of that class. So consider a program that uses a string variable to represent the suit of a card. Here we have a variable named suit. It's of type string, and we have instantiated it to hold the value of hearts inside that string called suits. But what if the user decides to set a suit to something invalid like triangle? Well, because triangle is a string, it would accept that, but however, that would not be good for our coding. It would not go well. So we can define them as such. We make them public so they're accessible to other classes. It is of type enum, and it is a suit, and we have here the predefined 4 different suits that we're going to use. Now, just like with a class, we can declare a variable of type suit. So now then, just like the class, it is capitalized, and we can then create a card suit variable, and then assign it a value from our enum of suits. So we define our enums. We say it is a suit. That becomes a class, so we can then assign a variable to hold some information in, and then we can assign some sort of a information into that variable or instantiate it. Okay, so suppose we're writing a Java class to represent a card. What attributes would a card have? Well, I would think maybe a card might need to have a suit and possibly a rank, being like ace through king or 2 through ace. But probably those two things would need to be defined in that. So for instance, a suit would be good. And you may even, I'm not sure about the rank as far as using an enum, maybe more like an array to store the values of the rank. But the suit itself, with only having 4 possible values, would be great for use of an enum there. Let's look here at this particular example. If we wanted to define a new variable to help with this program here, it says define an enum to represent the student classification type. How would you add a student classification attribute to the class below? Well, it would be an enum, but I would believe that because there are only 4 types of 4 different levels or grades in this particular example, I could use an enum to define, so it'd be public enum, and I would say maybe class or grade, and then inside the parameters you could put freshmen, sophomore, juniors, and seniors. That would be what I would think. So let's create, while we have some time before we move to interfaces, we're going to create a simple suit, like a card suit and a suit tester type program real quick and see how that looks. Okay, so I'm going to create 2 classes here, a suit class, a new class called suit, and I'm going to do another class called suit test, so I can test to see if it works. And my suit test will contain a main method, so I'm going to put that in there now. Okay, let's go with that suit class first. Let's go over this, and we are going to actually change it to define it as an enum at that point there. And the different types of suits we have available are going to be clubs, uh, diamonds, hearts, and spades. Now I wanted to do something kind of fun with this and print out their symbols along with that. So to do that, we're going to need to type in Unicode an escape clause. I've looked these up already, so the code for a club is 2663. And then with enums, you don't put a semicolon at the end of each one, only at the end of the last enum and its definitions. So then diamonds are going to be U266. And hearts are and spades are well, we'll come back to making sure that we can take care of those red right now, but we have defined our 4 enums, and inside this we're going to define a symbol so that we can print that symbol off, and that's going to be a variable of private type. Private is a string. Okay, so now I have that. I'm going to create my constructor now, so it should eliminate that red there. So it is we're going to make a suit class, suit constructor. Okay, so we've created a constructor. Now we've eliminated our red up there because the suit would now contain a symbol. So that's what it was expecting. It was expecting a suit and a symbol. Now we have a constructor to do that. So now let's keep looking at this here for a second. We need to probably get return values on these, and we need a toString. So let's get our symbol returned here. So our next method is going to be a public string get symbol, and all it's going to be is to return this string, this symbol, I'm sorry. And our toString method, I do not like to put R's in things. Do a little formatting here. Okay, we're going to return its name plus the symbol. Okay, that's all I'm going to have for my suit class. Let's go to our suit test class and take a look at that. In here we have our main method, and we're going to work inside there. So we need to create we're going to access our suit class. So it is capital letters. First letter is capital. So suit, we have a card, and we're going to say it is of suit type. Let's go with clubs first. Clubs. And from here, we're going to do a CISO, and we're going to put in just the ordinal value, which is the position on that. Okay. And then put a space in there for a little formatting, and then our card itself. So that should return for a club, its position, and hopefully through the toString it will print out the symbol as well. So I'm going to reproduce this to make my job easier for the other remaining suits. So I'm going to copy and paste that 3 more times. Now I do need to change these, and the fact that we've already predefined that card is of type suit, we can take out the type value now. And we do need to change that they're not all clubs. These are going to be clubs and like diamonds. And these should all be accessible. Hearts. So if I hit my dot operator, hearts. And this will be spades. Okay, so hopefully this will run and do a printout just like we have here below. I've already ran this before, so let's see if it does the same. And it does not. So I think what I need to do is to make sure I change my workspace to allow it to have access to UTF-8 coding. So I'm going to check that out under Windows, Preferences. On my workspace, let's see, UTF-8. Oh, that is applied. Apply it, apply and close. I did a little debugging there to find out why my symbols weren't printing out, and I realized that when I was defining my Unicode, I did the wrong slash. It needs to be the /, not the \. So if we change those up real quick, I believe that should resolve our issues. And now when we run it, it should produce a symbol down here for each of the different clubs, diamonds, hearts, and spades. So there you go. So we have our suit class. It uses a type of enum, and a tester class here that prints those out with a toString that has in it a symbol. So we've been looking forward to doing that. Okay, going back to our instructional piece, there's one last little bit for today, and we're going to talk about the interface, which we have done before, but it's pretty quick, this piece here. So what is an interface? Basically, the methods in a class are defined in a different, the methods of the class are defined in a different class so that it keeps them separate from basically the methods of the main method. So we can have our main method, and we have a dot operator to access the methods in our interface. So for instance, like this, we might have an interface called deck of cards interface. It has a couple of methods like a shuffle or a draw method in there, and any other public methods that we would want to have available. Now, this is the deck of cards interface. In another class, maybe a class called deck of cards, we're defining kind of how we're holding the cards and what kind of variables we might need here. But when we implement the deck of card interface, it pulls in that shuffle and draw method from the interface class. So let's take a look at how that does that real quick. So if I have a deck of cards, and it has a method in there right now of creating it, of swapping it, and a two-string method. So we have the ability to create new cards for this, but in my deck of cards interface, I have other methods like a shuffle method and a draw method, things of that nature. So I'm going to implement this interface into my deck of cards. So implement. Now it should say that I have some unimplemented methods. Oh, sorry, I did the wrong. It's that implements deck of cards interface. There we go. Now then, this highlights here and it says we need to add unimplemented methods. And as we do that, we should scroll down and possibly see the new ones from before, the shuffle and the draw, number of cards remaining, number of cards dealt cards. All of those have been brought into this deck of card class from the deck of cards interface as we implemented those. So that's how it's as simple as just implementing another class full of methods to help you out. Okay, so that should be it for today. And we will continue with this PowerPoint week 7 as we go throughout this week. Thank you, and I hope you have a good day.